So actually, sorry, sis, that they're recording. So you should.
No, he's good. Oh yeah, like little bit. Move the table, guys. You can move the table too. Yeah, you're good. You're good. Thank you.
They were talking because a bunch of people couldn't make it because of the fires, and so that's what people are recording.
Can you guys go back hear me?
Yes.
Awesome. Have a seat. So thank you for coming down. I know the fires were bad and traffic was horrible. So thanks once again for making it. For those who couldn't make it, we will record this and post it pretty soon, maybe by tomorrow itself. Great talk. To talk about AI, talk about TensorFlow, talk about Spark. We have great store topics. And then before we get started, I want to thank our hosts, Dizzy. So we have Ben, we have Lauren, we have Louisa. Please give them a round of applause for helping us host the event. So one quick thing, we're going to go a little bit longer this time because we have until about 8 o'clock. We can do the talk and then 8 to 9 you guys can hang around. So Chris is probably going to go hour 15 or 20 and 15 to 10 to 15 minutes of Q&A at the end. So you guys should be able to keep through the slides. Chris has informed me that he does a webinar. He actually has 160 slides. I don't think he's going to do it. So he's doing a webinar on Saturday between 9 and 1. And Chris has told that everyone who's part of this group will be getting a code. So you guys can attend that webinar. That'll be much more detailed, much more follow through. You can actually have the laptops.
So this Saturday?
Yeah, this Saturday. So Chris will talk more about it in the slides and we'll flash the code at some point. Alright, without further ado, I want to introduce Chris. So Chris, it's not Chris's first time really. He's spoken in my meetups a couple of times before. So he is down here for NIPS. And I wanted him to come and talk. So Chris is already here. When he come here talking, he was more than willing to do that. So give a round of applause for Chris and thanks guys.
Thanks everyone for coming. So I hope your house isn't on fire. Bigger things to worry about. Yeah, thank you, Disney. There was a tiny bit of question as to whether or not we were going to still do this, and Disney was like, let's do it. So, and traffic wasn't too bad at 3 o'clock. Yeah, so NIPS is at the Long Beach Convention Center. It's a great conference. It's sold out in like 4 days because it almost never, it's like not usually in the States, I guess. So but there's still about 3 or 4 days left. One thing real quick. Yes, I will flash the code here in a sec, and then I'll show it again later. It's Saturday from 9 to 1. I'm going to give everyone a GPU instance. I do this about once a month, and it's just enough time. I used to do an 8-hour workshop, and people start tomatoes after a while. And then I used to do them in person, and I think I was in London. And like one of the attendees was trying to find the bathroom and scratched this like 150-year-old marble door or something. And I was like, that's it. So it's much easier online. I can give you guys a GPU instance, and we'll do everything from like CUDA programming. There's about 10 notebooks. About 4 of them, we just go into the notebook and go straight into the terminal. It's just kind of a nice way to get to the terminal. And then we also do Python notebooks. And we're going to surface some like hidden gems within TensorFlow that not a lot of people know about, and it's more focused on post-training. So it's not necessarily during. It's not. We're still going to train models, but there's 8 million workshops and talks and things like that on like model training with the TensorFlow, and there's almost nothing on post-training. And that's exactly what my company I just started about a year ago, PipelineAI. So just give me 1 sec here. I want to get something started because it's going to take a second. Who here went to reInvent? last week. Anyone? Yeah, Subash went. Did anyone else go to the Amazon thing? A couple of huge announcements. There's this new service that they have called SageMaker, which is, yes, I used to work at like Databricks. I started with Netflix. I went to Databricks. I did a stint at the IBM Spark Tech Center, and we were always focused on trying to do what this SageMaker is, which is, like go in and spin up a notebook, have all the GPU drivers and the CUDA drivers all set up and all that stuff. So I'm going to walk through that here in a sec as well. I'm actually right now uploading a Docker image to Amazon's Docker registry, and then we'll be able to work with it from there. So just make sure it's cool. Yeah, so I have about 160 slides. It was 130 like a few days ago, and I added 30 on the plane down here. So we're definitely not going to get to all of them either today or on Saturday. But I'm going to skip around a little bit. There's like a whole bunch to cover, but I'll try to keep a consistent theme here. Who here has used TensorFlow? Yeah. Who here uses it in production? Oh, really? Okay. It's so funny because it's kind of like Spark was a couple years ago, right, Subash? Remember we would do like a poll like that? It would be, yeah, who's used Spark, and it was like 3 or 4 people, and then, yeah, who would think like just a couple years later everyone's using it? Yeah, who here uses Spark actually? All right, so I'm going to make a lot of parallels. I run this meetup called the Advanced Spark TensorFlow Meetup. Jump into the slides here. So, yeah, so I'll show you guys. Oh, yeah. So the title of this was first how to build Google Cloud, or the ML engine. So Google Cloud itself has something that is, they're trying to be like this SageMaker thing, right? So I'll explain SageMaker here in a sec. So since I created this title, it was basically trying to build Google Cloud ML. And we use Kubernetes for this, right? Like we're using like a lot of fun technologies, but at the end of the day, you don't want to manage your own infrastructure. It sucks, right? So even for people that are rather OPSy and systemsy, it's still not the best job in the world, right? There's like more challenges. Yes, one other funny thing, yes, Subash, right? Like he had to send me a tweet to get me to check my email to confirm for this thing. Yeah. So that was the exact tweet. I was like, oh shit, oh, it's a direct message like this. Which I still don't know the difference. I do them both interchangeably. Some quick news here. So as of today, actually, I just sent this out through LinkedIn and Twitter and all the dorky channels. PipelineAI supports the SageMaker thing. Also, about 2 or 3 months ago, we participated in this AI startup challenge that was run by the O'Reilly folks. There were 9 other startups, and there was robots next to us, and drones, and somehow we ended up winning this thing. We still had no idea. Because we're more of an infrastructure play, right? Like, so yeah. Also Netflix. So here's the meetup that I run. It's based in San Francisco. We have about 12 chapters throughout the world. All of this stuff goes on YouTube. Yes, are we recording, Subash? Yeah. Okay. Yeah, so we record everything, post it to this YouTube. You can go to pipeline.ai, and there's links right, for this kind of stuff. Okay, so I'm assuming you guys are data scientists, data engineers. You want to get models into production, right? Like, yeah, who here works with machine learning on a day-to-day basis? Yes, I'm going to ask you a lot of questions. TensorFlow guy. Yeah. So that's one thing. Like, there's this term. Actually, yes, I was just reading a paper by Google that was talking about the new TensorFlow estimator API, newish. And it's this term, train to serve. So like this is very different than like typical machine learning, right? Like these NIPS guys down in like Long Beach, right, like these guys work in the lab. They're there all day. They're not necessarily thinking about this thing being pushed out into production, right? To sit behind a Kafka stream or to take production traffic. So that's one thing I've actually seen at these academic conferences like throughout the years where there's a lot more talk about computational really type efficiencies and not just sort of theoretical stuff. So that's a good sign. But yeah, so one thing that we'll do more on Saturday, but we'll touch on here is train to serve. So we're training, but that's just a means to get to this complex business logic out really behind applications. Yeah, so right, like with any kind of cloud-based training, serving, there's really three big options, right? And of course, it's from the three big like cloud vendors. So my personal favorite, the one I've been focused on since it was announced last Wednesday, actually 1 week ago, is this thing called SageMaker. So this supports actually Spark ML also, which was kind of a shocker. I caught wind of this service about 2 or 3 months ago. And I thought it was just going to be, you know, maybe like they would do MXNet well. I thought it was just going to be kind of a service that they started and threw out and then, you know, sort of iterated. But like straight out of the box, it supports Scikit, it supports TensorFlow 1.4. It actually supports better TensorFlow than like Google's Cloud ML engine. And of course, it supports the Amazon MXNet product, which I think is an Apache project. So I'm not sure. But the cool thing is, it actually supports Spark ML. And there's tons of examples. So all of the typical linear regression, logistic regression, like decision trees, right? Like you could do that and actually train and serve. Well, not at the same time your first train, but you can then flip it over into serving mode. And it's as easy as just clicking, I want 16 GPUs of this rather instance type. This is stuff that at Databricks took about 20 engineers, right, to build. Is this SageMaker? Yes, I see a couple folks chuckling. This was the same thing that we were starting at IBM, which is now, I think, Data Science Experience, DSX. Right, like just getting that single button to go, you know, from the UI to an instance that has, right, like Jupyter Notebook and you know, has all the like GPU stuff installed. Yeah, so this is super easy to do. You could also actually train locally. So this is something I'll show you guys. This is the area where like Pipeline comes in. Is that we are going to take a model, and it's going to be TensorFlow. We're going to train it. We're then going to package it up inside Docker. So this is something I'm going to emphasize over and over here, is that we don't treat that model by itself anymore. Straight from the lab, put it really straight into a Docker runtime. So we basically hydrate these models or make them executable, right? And so now there's a REST endpoint or there's a Kafka endpoint or like something like that that you can get to. So it kind of gives life to these models. And what was cool about SageMaker is, so they show all of their models, their stock ones that they support. But then there's this tiny little thing that says, oh, by the way, you can upload any Docker image you want, just as long as it listens to this port, and it like obeys, has a ping endpoint, like a health check endpoint, things like that. And so that's where Pipeline comes in. So it supports custom Docker images. So this talk was supposed to be about Google Cloud ML Engine, and they support TensorFlow-ish. It's a little bit wonky. It's definitely not one-click kind of thing. It's very command line, and it's kind of a janky command line. Like you'll see. Yes, I shouldn't trash people too much. Yeah, I feel like I'm trashing them quite a bit. But like trying to find examples of Google Cloud ML Engine is like few and far between. And we're actually finding better examples from the developer advocates in the hallways of these kind of conferences than I do on the actual like website. Where I'm kind of looking over their shoulder and saying, "Oh yeah, that's that one parameter." So there's a lot of undocumented stuff. You can tell. I think the TensorFlow team itself, someone told me, is about 300 people currently. But yeah, I don't really know what they're doing. I mean, yeah, they're doing a lot, but more on the system side of things and not on kind of the user friendly. So that's the current state of things anyway. Yeah, I was super excited to see that like Amazon kind of leapfrogged. So one other area that like Amazon like really stepped up is the GPU area. So there's these new P3 instances that came out a couple months ago. That are the new Volta V100. And yeah, this Volta thing blows me away. I'll explain why here in a sec. I don't know too much about Microsoft Azure. Yes, as it says, I lost my Hotmail password a couple of years ago, and I can't seem to recover it. It's tied to like an old college phone number or something like that. So if you guys go here right now, there's actually right on the front README, there's step-by-step, rather, how to reproduce all this stuff. And yes, I even have instructions here on how to get those Docker images up to rather Amazon and then serve them through SageMaker. One little funny bullet point, and actually we're going to possibly start the fundraising process here in like January. As currently these VCs disappear for the winter, they all go to Africa to do safaris, is what I hear. They come back for CES. I don't know why CES is such a pivotal moment to these guys, but that's when they start up again. And one talk I had right before they all went to Africa was with a super high profile VC. I'm not going to say the name because I will never get funded. But right, like they essentially said, okay, so you have 2,000 stars, and 2,000 stars are worth $3 million. And that's the highest you can get with 2,000 GitHub stars. And that was literally the metric that they were going with. So if you do the complex math, a bunch of gradient descent, everything, you can get to $15,000 per like GitHub star. So the short of this slide is to please start this repo. Because each of you will put $15,000 into our pocket that we can burn. This is what we'll be using on Saturday. And here's the code actually. So if you go to PipelineAI, go to the workshops tab. There's a little button there to attend the workshop, and it's $200. So so I pay for all the GPU stuff. So don't invite too many people. There's already about 30 people signed up for it. So, but yeah, I want to extend this to you guys. Now, let's see. Yeah, so why do we focus on this model survey stuff, right? Like, why do we? So most people focus on training. So to us, coming from Databricks, coming from places like Netflix, we've done the batch stuff. This is kind of boring, right? And this is slightly offensive to those data scientists out there that spend their time doing batch processing and ETL and that kind of stuff, and that 80% of your time is being spent ETL. We're trying to stay out of that market. There's a million people that are part of that market. And what we like is this sort of real-time stuff, right? So, and like real-time, could be a REST endpoint, but we're seeing a lot of Kafka, we're seeing Kinesis, things like that. And it's more than just actually taking an HTTP request. This is also the ability to experiment quickly on live production data, right? So this is where we merge our knowledge of like canary deployments and typical what are now best practices for microservices, but we're now applying them to the data science world, right? So if I can get the demo, I have a demo running on Kubernetes with 3 models, and then we've got 3 models over in SageMaker. And if we have time, I'll actually spray traffic to all 6 of those. So think of extending your pipeline into production. So your model validation step typically is done offline, and it's typically accuracy. You're looking at validation accuracy on a pulled out data set. If you can also validate that model in production in a controlled way, so just 0.1% traffic to it, right, and just see the response time. Did you create a 100-layer deep model that is like 99.9%, and it's like totally overfitting, but then it's great on the offline, but now it takes 15 seconds per prediction, right? So this is this feedback loop of being able to do hyperparameter tuning, not just offline metrics, but these online metrics. So you can start to make adjustments offline and see how they affect online, and then circle that back. So the other thing too is, there's a relatively small number of data scientists, right? Like some of you guys, I'm sure, are on 60-person data science teams. But I think it's Stitch Fix. I think they have like 90 data scientists on staff, or so. It's like most for that size of a company. But it's still dwarfed by the number of application users, right? So users of your app or application developers that depend on this sort of rather real-time interaction. So yeah, outages, And rather optimizations that can happen at like this layer can rather really scale out. Yeah, so you can make training as fast as you want, and it's going to go from 2 weeks down to 1 week, but it's still a week, right? And here, these like small little milliseconds, rather multiplied by rather millions, yeah, this is huge, huge savings. And it's fun. All right, so something that I will keep emphasizing is packaging this model into the runtime. And there's no better way than using Docker where you can control the dependencies. So this is a snippet right out of that like pipeline repo where you can build the Docker image locally. So here's kind of the underlying thing here too, is that you can specify the version of scikit-learn, TensorFlow, right, down to NumPy 1.13. Yeah, we're like fully Conda compliant, so we support Conda RC, which does all the proxies through your, yeah, so all these like little nuances, right, like we did all these with our like early beta people. But now this is actually on your laptop creating this Docker image that's now the thing that goes through your CI system or CI system, right? But now this is the thing that goes from your laptop, which you can actually load test. So let me skip to the next slide here. So here we can actually load test on our laptop with that exact model, the same exact runtime. Yes, all the same things that will end up in production. So this is huge. Right, like what this gives you is the ability to create a model, right, like load test it, see that it takes 24 milliseconds for like 99.5 percentile, and then you can create another version and just get a quick rough idea on the same data set, the same laptop, right? This isn't production like numbers, but you're not really interested in the true production right now. I'm just looking at the first version A and second version B. If B is like 120 milliseconds, then just throw that away. He's not the way to go. So don't even push it out. One thing that we kept hearing over and over from people was when they push out a model to, they sort of hand this model over to the ops guys or to the ML engineer or to someone, right? Like they were never sure if it was the right libraries, the right versions. Maybe someone else pushed scikit 0.18 out or whatever, right? And so this is, true, right? Like happiness. This is that same Docker image being deployed everywhere. Oh, and so the other thing too is that you can actually try out different runtimes. So one cool thing about TensorFlow, right, like this is one reason that we really like TensorFlow, is there's a whole ton of support coming out. Let me jump to the next one here. For example, there's something called TensorRT. So I'm actually working with the NVIDIA guys. I'll be meeting with them next week back in San Francisco to get this going. So this is the third release of TensorRT, and this is their runtime. This is their optimized runtime for the GPU, for their physical hardware. Right? So who better knows these GPUs than these CUDA, right? These like CUDA developers. So they do a lot of tricks. They're kind of buried in some of the slides later. But yeah, so they actually have a Rust endpoint too. So this is something that you could package up and compare, right? So right now, if you're using TensorFlow serving, or if you're just taking your like Python and just calling session.run, which is the absolute slowest way to make predictions with TensorFlow, all three of these can be put side by side. So there's the slow Python way, there's the faster TensorFlow way, and there's the super optimized GPU version. And all three of these can be rather compared in production on just a tiny bit of traffic. And then you can tear them down if they're doing poorly and then shift the traffic back. On mirroring traffic, so this is always like the holy grail. Yes, everyone talks about it, but no one really is doing it. Where we actually do these tricks where like model A will be servicing production, and then B and C will actually subscribe to model A. And so in like an asynchronous manner, right, like traffic's coming in, it's being stored, it's being sent back to the user in real time. But A is, so B and C are pulling, right, these inputs, they're storing it themselves, and then we're really showing that in a nice dashboard in real time. So we can actually see how three models are scoring at the same time, right when they get deployed. Not right, like 12 hours later after the Hive job comes and all that kind of stuff. Yeah, so one other thing too that is really sweeping the GPU nation these days is this half precision support. So half precision is the new full precision. It's 16-bit essentially, or even down to 8-bit. So this comes up a lot when you're serving a model. When you train a model, right, like you want the most accurate model possible. So the more bits that you can use to represent the floats that you're learning, the weights that you're learning, right, like the better off you are. At serving time, or like prediction time, what you're trying to optimize is speed, right? And so multiplying two floating point 16s is way faster than multiplying two floating point 32s. And there's a hardware reason for this as well, too. These GPUs can actually pipeline two floating point 16s into one single floating point 32. And there's 5,000 of these GPU cores, right? So 16-bit, we'll show here this new Volta chip, which is the P3. This is, oh yeah, so I didn't finish my thought there. Google just came out with the P100s, which was last year's GPU on their Google Cloud. And then, you know, people were kind of sitting around waiting for Amazon to do something, because Amazon had these old K80s, right? And everyone was kind of laughing at them. And then they're like, well, haha, we have the new Volta V100, right when it dropped out of my video. So I'll show some benchmarks here in a sec, comparing the K80, actually the P100 to the V100. I'm sure that Google will come out with the V100 at some point. I'm sure it's going to be next year sometime. Of course, Google is sort of banking on their TPUs, and so that's another area too that you can actually compare. So you can compare CPU, GPU, TPU. Yeah, so no one really has access to these TPUs yet. They're supposed to be blazing fast, especially on the forward propagation, which is the serving. And yeah, I think I might have, yeah, so I do have a slide on this later, but the new Volta V100 has, right, these tensor cores, which are the closest thing to TPU. So they have both the like traditional GPU cores and tensor cores. And so they're side by side. There's 5,000 GPU cores and I think 700 of these tensor cores. So and I'm working with a couple like hardware startups right now that are like basically optimizing directly for TensorFlow. So one cool thing about, well, the third or fourth cool thing about TensorFlow is there's a sort of intermediate language that it's called XLA. And it's like a compiler IR kind of thing. It's like getting it down to like LLVM, and then someone else kind of takes over. And that's not exactly true, because they actually do use LLVM to get to the last mile. But if you are a hardware manufacturer startup and you want to right now start to optimize your chip for something, it's going to be TensorFlow. It's going to be that XLA. Think of like this XLA stuff like a logical query plan to a physical query plan. So right, like the XLA is kind of in the middle. It's like the logical optimized plan, and then people can kind of come in and then write specifically to their hardware. Yeah, there's some other tricks here too you can do at serving time, like change the size of the request batches. So if you're under high throughput, you can actually batch up or say, right, like 10 milliseconds, just batch up all the matrix multiplies into one big matrix, pass it to the GPU, make one big matrix multiply, pull it back, and because of linear algebra, right, yes, we can slice up the result and send it back to each column. That could be devices across the world that happen to end up on the same server. Serving supports, something TensorRT supports as well too. And so again, these are the knobs that data scientists right now don't have access to turn. When they hand that model over, all they have access